So here is another question. So it is given that the position of an object moving along x-axis is given by the expression x is equal to a plus bt square, where a is equal to 8.5 meters, b is equal to 2.5 meter per second square, and t is measured in seconds. It has been asked what is the velocity of the object at time instants t equals to 0 seconds and t equals to 2 seconds. This is the first bit. Second bit is what is the average velocity of this object between t equals to 2 seconds and t equals to 4 seconds. Okay, this. Okay, so first thing, here the displacement or the position that is given by a plus b t square. Okay, this. In order to find the velocity at these specific time instants, we have to get the expression of instantaneous velocity, that is equal to v is equal to dx by dt. Okay, this v is equal to dx by dt. So here d by dt of a plus bt square, that will be equal to 2bt. Okay, so here in order to find the velocity of the object at specific time instant v at t equals to 0 seconds, we simply need to substitute this t equals to 0 here. It will be equal to 2b into 0, which will be equal to 0 meters per second. Okay, the unit is meter per second. So the velocity of the object at t equals to 0 seconds is 0. Then the second part, the velocity at t equals to 2 seconds. It will be equal to 2b, in place of t will substitute 2. So it will be equal to 4b meter per second. For b, the value of b here is given as 2.5. So it will be equal to 4 into 2.5, which is equal to 10 meters per second. 10 meters per second. So the velocity of the object at t equals to 2 seconds is 10 meters per second. Okay, this is the first bit complete. Then it has been asked to find the average velocity between t equals to 2 seconds and t equals to 4 seconds. Now if you remember, average velocity is given by delta x by delta t. Okay, change in position by change in time of the time interval. So here it will be in between the final displacement minus initial displacement, or final position minus initial position, divided by final time minus initial time. So here final position is this, the position of the particle at t equals to 4 seconds. Okay, x at t equals to 4 seconds, which is equal to a plus bt square at t equals to 4 seconds. Which is equal to a plus b into 4 square, that is equal to a plus 16b. Okay, now let us keep like it, okay, this like that. Okay, don't substitute it right now, don't substitute the values of a and b right now. Then the initial position xi is equal to the position of the particle at t equals to 2 seconds. Okay, t equals to 2 seconds. This is the starting time, the start of the interval. That is equal to a plus b into 2 square. Okay, simply in place of t you substitute 2. That is equal to a plus 4b. Now here Ti is equal to 2 seconds, Tf is equal to 4 seconds. Now we'll substitute it here. Xf minus Xi, which is equal to A plus 16B minus Xi is A plus 4B. Tf minus Ti, Tf is 4 seconds, initial time is 2 seconds, final time is 4 seconds, okay, initial time is 2 seconds. So this will be equal to A plus 16B minus A minus 4B. This will get cancelled by 2, will be equal to 12B by 2, which is equal to 6B meters per second, the average velocity, which is equal to 6 into, we substitute the value of B, which is equal to 2.5. That is equal to how much? 15 meters per second. Okay, so the average velocity in between t equals to 2 seconds to t equals to 4 seconds, that is equal to 15 meters per second. This. Okay, this. Hello friends, so here is another question. So it has been given that the velocity of a particle is given by the equation, the expression v is equal to 2t square plus 5 meters per second. It has been asked to find the change in velocity of the particle during the time interval from initial time t1 equals to 2 seconds to final time t2 equals to 4 seconds. Find the average acceleration of the particle during the above interval, that is from t equals to 2 seconds to 4 seconds, and to find the instantaneous acceleration at t2 equals to 4 seconds. Okay, so as it is given, it is clear that it is based on the concept of instantaneous acceleration and average acceleration. Okay, so v is equal to 2t square plus 5 meters per second. First bit, to find the change in velocity from t1 equals 2 second to t2 equals to 4 second. So first we have to find the velocity at t1 equals to 2 seconds. Simply substitute t with 2 seconds, 2 square plus 5, which is equal to 8 plus 5, which is equal to 13 meters per second. Similarly, velocity at t2 equals to 4 seconds, 2 into 4 square plus 5, simply substitute t with 4, that will be equal to how much? It is coming around 2 into 4 square 16, 32, 37 meters per second. Okay, 4 square 16, 16 into 2 32 plus 5, 37 meter per second. So change in velocity delta v is equal to here v2 minus v1, which is velocity at t equals to 4 seconds, that is t2 equals to 4 seconds, minus velocity at t1 equals to 2 seconds. Okay, final velocity minus initial velocity, which is 37 minus 13 meters per second, which is equal to 24 meters per second. Okay, this. Then it has been asked to find the average acceleration. So average acceleration over the same interval, that is 2 to 4 seconds. It will be the same delta v by delta t. Here already we have found delta v equals to 24 meter per second from 2 to 4 second. Okay, this, and delta t is 4 minus 2 seconds, which is equal to 24 by 2, which is equal to 12 meters per second square. This is the average acceleration over the time interval 2 to 4 seconds. Then the instantaneous acceleration at t equals to t2 equals to 4 seconds. Now instantaneous acceleration, that is equal to dv by dt equal to d by dt of 2t square plus 5, okay, and that is equal to 4t. Now instantaneous acceleration at t2 equals to 4 seconds, it is simply we substitute t with 4, which is equal to 16 meters per second square, 4 into 4, okay, 4 into 4, 16 meter per second square. Okay, this, okay, this. So these are the questions that we have discussed so far, these are very simple and straightforward questions. We are deliberately, solving these questions so that you get acquainted with these concepts. In the next series of videos, we will be covering more advanced, complicated things, equations of motion. So there it will come in handy. So the reason why I am making you, practice all these questions so that you get more and more acquainted, adjusted with these things, And the next time when we discuss these, there I will not I will not give these details again. I will simply say average acceleration. So you will quickly understand average acceleration means this. I will say instantaneous acceleration. So you will quickly understand it is derivative of this. I will say, let's say instantaneous acceleration. So you will quickly understand that. Okay, so like that. So here is another question. So it is given that the acceleration of a particle is given by a is equal to 3t square plus 2t plus 2. Unit is meter per second square obviously, where t is in seconds. And it has been given that if the particle starts with an initial velocity of v is equal to 2 meter per second at t equals to 0 seconds, that is the initial velocity, then find the velocity at the end of 2 seconds. Okay. So here we know acceleration is equal to dv by dt, rate of change of velocity with respect to time. Okay. So that implies dv is equal to a dt. Okay. So here if we substitute the value, dv is equal to a is equal to 3t square plus 2t plus 2, 3t square plus 2t plus 2 dt. So integrating both sides, we will get implies v is equal to 3t cube by 3 plus 2t square by 2 plus 2t plus c, constant. 3 got cancelled, 2 got cancelled. This is equal to t cube plus t square plus 2t plus c. Now it has been given that the velocity at the initial time t equals to 0 seconds is equal to 2 meter per second. So v at t equals to 0 seconds, it is equal to 0 cube plus 0 square plus 2 into 0 plus c, that is equal to 2 meters per second. So the value of this constant is equal to 2 meters per second. That is very important. Then it has been asked to find the velocity at the end of t equals to 2 seconds. So that is we have to find the velocity at t equals to 2 seconds. So simply substituting the values here in this expression, okay, in this expression, 2 cube plus 2 square plus 2 into 2, and the value of constant is 2. So it is 8 plus 4 plus 4 plus 2, that is equal to 12, 16, 18 meters per second. So the velocity at t equals to 2 seconds is equal to 18 meters per second. Okay, yes.